Good day, students. Welcome to math.sorryb.com. In this clip, we're going to be going over how to solve quadratic inequalities algebraically and graphically. So the instruction for this problem is as follows. We're to solve the given inequality algebraically and graphically. Okay. The graphical approach is much faster, but the steps involved in the algebraic solution is very important in preparing you for some of the procedures you'll be encountering in precalculus and also in AP calculus. So let's go ahead and take a look at the inequality that we're dealing with. We have 2x squared plus 3x minus 1 is greater than 1. Okay, so let's say this is the quadratic inequality we are to solve algebraically and graphically. So let's start with the first method, the algebraic solution. So let's title it method 1 is algebraic. Okay, whenever you think of solving quadratic inequalities algebraically, you want to think about the acronym CVS. Okay, CVS, like the store you go to get your prescription medication. Think about CV as your critical values. Okay, critical values, and then think about S as your sign chart. So these are the two components that are needed in order to solve quadratic inequalities algebraically. Okay, so let's go ahead and write down the inequality that we're dealing with. 2x squared plus 3x minus 1 is greater than 1. Now, in order to find the critical values, we'll have to set this equal to 0. So let's rewrite this inequality in standard form first. So that will help us greatly as we proceed with the problem solving process. So to have 0 on the right side, we simply subtract 1 from both sides of the inequality. So we have 2x squared plus 3x minus 2 greater than 0. Okay, so now we have it in this format. Let's proceed with part 1 of the algebraic process, which is to find the critical values. Okay, so what are the critical values? These are what you get when you set your equation equal to 0 and solve. What x values cause the equation when set to 0 to have an output of 0? That's what we're looking for. Okay, so what we're going to do is we'll take this quadratic inequality that we have here, 2x squared plus 3x minus 2 greater than 0. We convert it into an equation. 2x squared plus 3x minus 2 equals 0. Now we have a quadratic trinomial. There are different ways that you can solve a quadratic trinomial equation. You can use the completing the square method, factoring the quadratic formula, or you can solve it graphically. We're going to attempt to use the factoring method here. Let's hope that works. If not, we will have to resort to using the quadratic formula because that always works. We're going to put AC on top and B on the bottom. In this problem, A is 2, B is 3, and C is negative 2. So if we compute AC multiply 2 by negative 2, you have negative 4. And C is, B is 3. Okay, let's play the x game. So what two numbers multiply to give you -4 and add to give you 3? If you think about the possible combinations of numbers that yield the product of 4, think about 1 and 4. This works nicely. But in order to get a negative product and a positive sum, we need the smaller to be negative. Now, if you notice, the value of a is not equal to 1. So if a is not equal to 1, you have to solve this by factoring by grouping. Okay, so we have to factor by grouping. Had it been that a was equal to 1, then we can skip to the factored state. But that is not the case here. A is not 1, so we have to factor by grouping. We have 2x squared. Now let's insert the two numbers that we got from our x game. -1x plus 4x minus 2 equals 0. Now let's partition it right down the center and factor by grouping. From the first 2, the GCF is x, so we factor out x, and we're left with 2x minus 1. From the next 2, the GCF is positive 2, and we factor that out, we have 2x minus 1. At this point, you freeze and check your work. Make sure that the quantities in the parentheses are identical. And that is the case here, so our factorization process is accurate. Okay, so let's factor out the identical quantities, 2x minus 1. Now the terms on the outside, x and positive 2, can be clustered together in their own parentheses, x plus 2, and set equal to 0. Now we're going to use the zero product property to find our two critical values. That involves setting both quantities equal to 0. Okay, so let's go ahead and solve these two resulting equations by applying the zero product property to the previous step. So here we just add 1 and divide by 2. That will give us the first critical value. Let's do that. Add 1, you have 2x equals 1. And then you divide by 2. You have your first critical value, x equals 1/2. This causes the equation to attain an output value of 0. Now the second equation, we can simply solve that by subtracting 2 from both sides, and that gives us our second critical value, x equals -2. Now recall, we talked about CVS as the acronym to help us organize our steps. CV is the critical values. Okay, so now we'll proceed to the S part, which is the sign chart. Okay, so let's go ahead and do that. I'm going to partition my workspace. Let's create our sign chart. It just involves drawing a number line and graphing your critical values on the number line. So this is the original inequality. We have 2x squared plus 3x minus 2 is greater than 0. Since there is no equal to symbol here, it basically tells us that the critical values are not included in the solution region. Okay, so let's say this is -2 right here, and then we have 1/2. We're going to use an open circle because those two values are excluded from our solution region. Okay, so we have an open circle there, and I want to partition the region so you can clearly see what's going on. Okay, now how many regions do we have here? We have region 1, which is to any number that's smaller than -2. We have region 2 between -2 and 1/2, and then region 3. Now what we're going to do is we're going to pick test values that we can plug into the inequality and see which one generates a true statement. Okay, so let's see what we have. For interval 1, we'll think about a number that's easy to work with, that is less than -2. We can use x equals -3. Now interval 2, think about a number between -1/2 and +1/2. That is easy to work with. We can use x equals 0. And then to the right of 1/2, we can use x equals +1. Okay? Now, what we're doing is we want to see where this inequality is greater than 0. What do we know about the sign of a number that is greater than 0? It's positive, okay? So any of these input values that results in this expression attaining a positive value, that interval, the interval that contains that test value, will be a valid solution region. Okay? So it's easier to work with the factored form of this inequality. We already have it factored here, so we can express this as 2x minus 1 times x plus 2 greater than 0. Okay? Alright, let's go ahead and proceed with our test. We're going to test interval number 1. For interval 1, we have x equals -3. So we're going to plug it into this inequality right here. So it's 2 times -3 minus 1 times -3 plus 2. Is it positive? That's the question. So what I really care about here is the sign of my final result. I don't care too much about the numerical part, okay? So if you work this out, -3 times 2 is -6 minus 1. This whole first parenthesis will be negative, okay? It's going to attain a negative value because you have -6 minus 1, which is -7. The second parenthesis, you have -3 plus 2. That's going to give us a negative answer. If you multiply two negative numbers, do you end up with a positive number? Minus times minus is plus. Is plus greater than 0? The answer is yes. This is a true statement. Okay? Remember, we're just comparing it with 0. If it's positive, then it's true. If not, then it's false. Okay? Now we know that interval 1 is good because we have a positive sign, and positivity means that the result is greater than 0. Now whenever you are solving quadratic inequalities algebraically, if there are solutions that are not a double root, if you have solutions, then it's either going to be the outside, the exterior intervals, or the interior. That's always the pattern. So since interval 1 is already a solution, then we automatically should expect interval 3 to be a solution, and for interval 2 not to be a solution. So it's always either the two outer regions or the inner region. Okay? So let's keep that in mind. So we already know what the answer is technically, but let's go through the whole process, test the other values, and see if our claim is true. Next test is interval 2. We're going to be using x equals 0. So for interval 2, we are taking a look at x equals 0. We're going to plug it into this inequality. So it's 2 times 0 minus 1 times 0 plus 2. Is it greater than 0? Is it positive? That is the question. So 2 times 0 is 0 minus 1. This will have a negative answer. 0 plus 2, this will have a positive result. Is negative times positive greater than 0? Negative times positive is negative. Is a negative number bigger than 0? The answer is no. Okay, negative numbers are smaller than 0. That tells us that interval 2 is no good because of its negative sign. In order to be greater than 0, you must have a positive sign, just like we did in interval 1. Now let's go ahead and take a look at the last test. We're going to test x equals, what did we pick for interval 3? 1. We're going to plug it into the inequality, so we have 2 times 1 minus 1 times 1 plus 2. Is this greater than 0, or is it positive? 2 times 1 is 2, minus 1 is 1. 1 times 1 plus 2 is 3. Is 1 times 3 greater than 0? 1 times 3 is 3. Well, let's see. We're focusing on the sign, so let's just use the sign here. So this one right here is going to be positive, and then this one right here is positive. So is it positive times positive greater than 0? Positive times positive is positive. Is a positive number greater than 0? Absolutely. So this is a true statement, which tells us that interval 3 is good because we have a positive sign there. Okay, so remember, these are our critical values. They are not the solutions. Okay, these are critical values. Critical values. Okay, they're not the answers. Now let's go ahead and write down the answer. The answer is basically interval 1 and 3. So what does it look like? It's going to be, you're going to from negative 2 to the left, and you're going from positive 1/2 to the right. And we're going to exclude the endpoints. Okay? Now how do we write that in interval notation or set or inequality notation? So for interval notation, you can write it as, this is our solution. Our region, we have x is less than negative 1/2, or x is greater than, x is less than negative 2, or x is greater than 1/2. If you want to write it using interval notation, you can go from negative infinity to negative 2 union 1/2 all the way to infinity. Okay, so these are the solutions to the quadratic inequality that we have presented in interval and inequality notations. Okay, let's proceed to use method 2. Is much faster, but it makes use of the critical values. So method 2 is the preferred method, which is known as a graphical method. The reason why I showed you method 1, as I indicated earlier, is that it's preparing you for some important procedures that you have to know in precalculus and AP calculus. So method 2, graphical, we're going to just start by taking a look at the critical values. The critical values are basically what we're going to use to sketch the graph. So we have x equals positive 1/2 and negative 2. So critical values are x equals negative 2 and positive 1/2. Let me go back and make sure. Okay, so we just graph it. Now your graph doesn't have to be perfect. All you just want to do is take a look at the quadratic function and see which portion of it satisfies the condition that's being placed on it. Alright, so what we're going to do is graph the quadratic. The quadratic that we're looking at, again, is 2x squared plus 3x minus 2 is greater than 0. So what we're going to do is we're going to graph the related function. We're graphing y. We're going to graph y is equal to 2x squared plus 3x minus 2. Okay, and then after that, we'll take a look at the effects. Okay, let's go ahead and do it. So we have the critical values. So this is -1, -2, right there, and then this is +1. So 1/2 will be to the left of +1. So this is 1 right here, and then this is 1/2. Okay, so we have an open circle here, and then we also have an open circle there. Those are your critical values. We have open circles because there's no inclusion line underneath our inequality. Okay, so if you graph this function, we know that a is equal to 2, which is greater than 0. So that means that our parabola opens up. Okay, so we have our parabola looking something like this, opening up, and then this one something like that. Let me fix this real quick. Okay, so what we are looking for is where the function 2x squared plus 3x minus 2 is greater than 0. So what portion of this quadratic curve is greater than 0? Now remember, if you are below the x-axis, you're less than 0. If you are above the x-axis, you're greater than 0. And then if you're on the x-axis, you have x equals 0. Okay, you're equal to 0. So what are we looking for here? Greater than 0, we're looking for the parts of the function that is above the x-axis. Okay, so let's go ahead and highlight those regions. Okay, so the regions are going to basically be this region right here. That's the region that's above the x-axis. And then we have this region right here that's above the x-axis too. Okay, so what we're going to do now is basically project these two regions onto the x-axis. Okay, these ones are on the outside. So if we project it on the x-axis, they'll end up looking something like this. You have an open circle here, of course, and then you're going to be going to the right because that's the projection of the region that we just graphed on the x-axis. So we have something like that going there, and then this point going to the right. Okay, and of course you have an open circle here and an open circle there. So let me show you what I mean by projection. You take this entire thing and then you project it down to your x-axis. Okay, so what you end up with is your solution region. Our solution region are the portions in green on our x-axis. Okay, so let's go ahead and write it down. Our solution is going to be x is, let me change that. X is less than -2, or x is greater than +1/2. And that's our solution to the quadratic inequality using the graphing method. As you can see, the graphing method is by far more easier and visual to see, but the algebraic method, although it's involved, it certainly teaches you some very important skills that you'll be using in precalculus and AP calculus. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you've found the contents of this tutorial helpful in your study of quadratic inequalities, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any comments or questions about what we covered in this presentation, just place your question in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.